Okay, we're going to be looking at some cubic and quartic functions. It would be really good for you to read through the first couple of pages with relation to cubics and quartics at the start of the chapter. The thing that you should be aware of is cubic functions have a highest order of x cubed. Quartic functions have a higher order of x to the power of 4. And their shapes will vary a little bit more than what they do with the linear graphs and quadratic graphs that we've seen so far. Something that would be really good for you initially is to actually just plot a graph of y equals x cubed. We'll start with that one. So y equals x cubed. And the whole point of this is just for you to get an idea of the shape of what the graph does. So I'll make a bit of a table here. X and y, and what we can do is -3, -2, -1. I'm going to add a little one in here, -0.5. I'm going to write that 5 in there, like that. 0 and 0.5, 1, 2 and 3. Now you can calculate those values, and I'll get you to pause it right now so that you can have a go at filling those values in. I did say to pause it. And while you're completing that, I think I might just draw up a set of axes very quickly. I'd like you to do this on graph paper, which will give you a better idea of the shape of the graph. Unfortunately, I don't have any graph paper on this particular thing. -3, 3, and we don't know how high we're going with this, so I'm just going to go 2, 4, 6, -2, -4, -6, and we'll go to -8 down there. -8 would actually be at the top of this arrow at the top there. Right, I'm just going to start filling in these values. So 3 cubed is 3 times 3 times 3, which is 27. So -3 times -3 times -3 will be -27. -2 cubed will be -8. -1 cubed is -1. And -0.5 cubed, I'm going to use my calculator for that. Is -0.125, or -1/8. Now, a little side note onto that one there. If we're going to be using a half and cubing it, then if you remember your index laws, that would be the same as 1 cubed over 2 cubed, which is 1 divided by 2 cubed is 2 times 2 times 2, which is 8. So that's the fraction of 1/8, and 1/8 is equal to 0.125. And as you play around with fractions a little bit, you'll get to see that 0.125 does come up a little bit. 0 cubed is 0, so this is going to be 1/8, 1, 8, and positive 27. Now to plot these points, -3, that's just going to go right off the scale here, but your graph paper will be, your graph will be a lot bigger, but you'll still get an idea of the shape of the graph from this one. -2 goes down to -8, so we've got a point there. Okay, -1 is at -1, so that's going to be a point right in there. -0.5 is -1/8, so on this scale it's going to be just below the horizontal axis. At 0 is 0, and then at +0.5 it's right in there. At 1 it's going to be 1, 2 it's going to be +8, way up there, and then 3 again goes off the scale. Now the whole point of me wanting you to plot this is so that you could see the shape of the graph. When we go to join the lines, I might get a slightly different colour to do that, is the graph will come up. Sorry for not getting through it. This pen is a little bit tricky sometimes to make accurate. So the curve comes around and it does actually sort of flatten out right in the middle there, and then it starts to sort of S around the other direction like so, and then it just goes really steep, so it would actually go right up really high. So it is a sort of like an S-shaped graph that you draw. So that's the type of thing that you need to become familiar with regard to the shape of a cubic graph. Now we're going to move into translation. I'm just going to add another page here. So for a cubic graph, it does have a general form of y equals a... Okay, continuing on, sorry about that. There, x minus h cubed. That's the general form of an equation. Then we go plus k on the end. Now, if you remember back to quadratics, this section inside the bracket will shift it sideways. If it's negative, it'll go to the right. If it's positive, it'll go to the left. And the k will shift it up or down. So we have our vertical translations and the horizontal translations. So an example of that would be is if we were to, and a lot of this will come into sketch graphs, we have our basic form of the cubic equation, which is something like that. If we were to have a graph of y equals we'll go x minus 3 cubed, what we have there is we have a horizontal translation only, so it's going to shift it to the right by 3, so it would actually come across and look something like this. So it would be the same shape, but it's just been shifted across by 3. If we had a graph of y equals x minus 3 cubed minus 2, that minus 2 on the end is going to shift the whole thing down by 2. So it'll be the same shape graph, shifted down, like so. These are pretty rough drawings, so it's always good. I'll initially use graph paper, get an idea of the shape of the graph, and then go from there. If we were to give you one more example, y equals x plus 2 cubed plus 3. That is going to shift it to the left by 2, and it'll shift it up by 3. So we go to the left by 2 and up by 3. This is where the centre of the graph is going to be, so this will be a graph that looks something like that. If we had a value in front of it, something like, a red one, looking for different colours on here. So if we had a graph of something like y equals 4x minus 1 squared, cubed it should be, plus 1. Bit inside the bracket will move it to the right by 1. This bit at the end will move it up by 1. So our centre will go to the right and then up, so it'll be in there somewhere. This 4 at the front will make it really steep. So if you remember the shape of your original x cubed graph, you basically multiply each of those values by 4. So with your original x cubed graph, if you went to -1 and +1, it went up by 1 and down by 1. In this case it would go up by 4 and down by 4. And 2 cubed was 8, so if you go to the left or right by 2, it would go up by a factor of 2 cubed, which is 8 multiplied by 4, which is 32. So a really steep graph this would be. Something a bit like that. And the other thing that you can do with this is you can also use your graphics calculator to get an idea of the shapes. So that's sort of the information initially with translations of cubics, and in a moment we'll do some quartics. And here we're doing quartics, which will have a general rule of y equals a x minus h to the power of 4 plus k. So the translations with quartics are exactly the same as the cubics, but what you need to do an idea of at the start is what does the shape of a quartic graph look like. So for a graph of y equals just x to the power of 4, again we'll make up a little table for this. I'm just going to go -2, -1, 0, 1, and 2. So -2 to the power of 4 is going to equal, get an orange there, -2 to the power of 4 is -2 by -2 by -2 by -2, which equals 2 2s are 4, 2s are 8, 2s are 16, and a negative times a negative is a positive, times another negative is a negative, times another negative is a positive. So the rule with negatives is if you have a power which is an even number, so that's 2, 4, 6, 8, 10, etc., then it'll always be a positive answer. If you have an odd number that you're multiplying together, so cubes, power of 3, power of 5, power of 7, etc., then it will be a negative number. So in this case here, we're looking at -2 cubed being positive 16, -1 cubed is 1, 0 cubed, to the power of 4, sorry, 0 to the power of 4 is 0, 1 to the power of 4 is 1, and 2 to the power of 4 is 16. So it's going to give you an idea of the shape of the graph. These graphs are very similar to an x squared type graph, but they're just a little bit flatter and steeper. So something like that is what the shape of the graph would look like. It does get very steep very quickly, and when you do your translations you do exactly the same thing. So if we had, for example, y equals x to the 4 plus 2, then the whole thing will be shifted up by 2, like so. And if we had a graph of y equals x plus 1 to the power of 4, then the whole thing would be shifted to the left by 1. So we take our original graph, shift it to the left by 1, something like that. And again we can have a combined rule where if we have a graph of y equals x minus 1 to the power of 4 plus 2, then it's going to shift it to the right by 1, it's going to shift it up by 2. So go to the right by 1, up by 2, it'll be a graph that looks something a bit like this one. Okay, and the rule with both of these again, yep, if we were to have a graph of y equals negative x cubed, so go back to the cubics for a minute, if you remember the original cubic graph went like that, then the negative cubic graph would be inverted, flipped upside down. Similarly, if we had a graph of y equals negative x to the power of 4, if you remember the graph of x to the power of 4 looks something like that, so the negative graph would be the inverted version of it. So that's what the effect of a negative out the front would do. Okay, that should, I think, give you enough information to go on with exercise 7a in your book. Okay.